Welcome to 6D, Part 1, Adding and Subtracting Rational Algebraic Expressions. You're using the same concepts you did with adding and subtracting fractions, like you did 5-6 years ago. Start off with a quick easy example of something you did in the past. 2/3 plus 5/18. Can't add these, they're not like bases yet, so you have to make them have like bases. Two is you either multiply both equations by each other's denominator, or you can actually take, and if you notice, 2/3 here, if you multiply the numerator and denominator by 6, that will change the denominator to be similar, the same as 5/18. So now we have like denominators, so now you can just add numerators. 17/18, and we're done. For example 1 here, simplifying, we have two different denominators. We have a binomial, a plus 4, and a monomial, 3. They're not like yet, so what we have to do is you multiply, most of the time, by multiplying one fraction by the other's denominator, and the other fraction by the other's denominator. It'll work out really well. So we have 3 times 5 is 15. We have 3 times a binomial, so that's 3 times a is 3a, plus 3 times 4 is 12. On the second fraction, we have 6 times, in parentheses, a plus 4, so we have to distribute that in. 6a squared plus 24a on the numerator. The denominator becomes 3a multiplied in, distribute. Now we have like denominators, so now we can look at our numerators and put them together. So put them together, we have 6a squared. I'm going to start with the biggest exponent first, plus 24a plus 15. It's all divided by 3a plus 12. Now sometimes you actually have to look at, can you simplify? So we look to see if we can simplify this now new fraction. So we look at the numerator. Is there anything we can do can we factor it? And I can see between 6, 24, and 15, I can factor out a 3. And what's left, we have 2a squared left side. By 24a by 3, you get 8a, and 15 by 3, you get 5. On the denominator, I see I can again factor out a 3. So I have a plus 4 left. And right now I see that I have 3 in the numerator, 3 in the denominator. 3 divided by 3 is 1. 1 times what's remaining. It's just what's remaining, so we just say they cancel. We can look to see if we can factor the numerator even more. Maybe we can get an a plus 4. So you put it in the calculator, graph it, get your 0. I'll just check one of them for now. Enter, right bound, enter, enter. And I get negative 0.775251. That's an irrational number. It doesn't repeat, doesn't end. So therefore, the numerator cannot be factored further. And the final answer is 2a squared plus 8a plus 5 all over a plus 4. Moving on. Simplify it again. In this case, sometimes it might be beneficial if you factor right away. So if I look at the problem, and I can see that the denominator, first denominator, I can factor out the greatest common factor of 2x. So I'm going to rewrite the problem, factor out a 2x. That's x plus 3 left over, and minus, on the second fraction, you have 5 divided by 2x. Well, now I see both of my denominators have two x's in them. The only difference is one has an x plus 3 and the other does not. So only thing you really have to do is multiply the second fraction by x plus 3 over x plus 3. This will give us like denominators. And if you didn't factor right away, you would not have seen this, most likely. So, multiplying that out, we have parentheses. I'm just going to carry this first fraction down. Subtract 5x plus 15. Distribute that 2x in. 2x. Oh, actually, you don't have to distribute it in. You can just leave it. It actually is beneficial for the next step. So we know we have like denominators. We have a 2x times x plus 3 and a 2x times x plus 3. So I'm going to bring that across. And in the numerator we have 5, subtracting all of this, 5x minus 15. So I have, if I distribute this negative in, I will have a negative 5x, and 5 minus 15 is negative 10. I now want to see if I can factor the numerator, and I can see that I can take out a negative 5. Let's see, if we take a negative 5 out, we have x plus 2 left over. And the denominator, we have x plus 3. Nothing in the numerator and denominator are like terms that we can cancel out, so here's your final answer. For the third example, we need to, again, factor the numerators and denominators. In this case, only the denominators are factorable. So we look at the first factor, or first denominator of the first fraction. And you can put this into the calculator if you'd like and find the x-intercepts. But last unit we studied factoring. And this is a perfect square binomial. So we can factor the denominator into subtraction in between, so it's x minus 4 and x plus 4. Only works, perfect square binomials only work when there's a subtraction in between the binomials for the terms. The second one, you can put that into the calculator if you'd like, which I did here. Put it into the calculator. There is a trick to this one. Both first and last term are perfect squares. But let's check if I put it in the graph. Let's go to the table. We'll see that at negative 4 is there 0. And it looked to be a double. So negative 4. So the factor is x plus 4. I'll write that twice because it's a double. Now, once we have everything factored, we look at our denominators, and they're very, very similar. The only thing that's different is I have an x plus 4, or one extra x plus 4 on the right fraction, and I have an x minus 4 on the left fraction. So what I'm going to end up doing, multiplying the first fraction by another x plus 4 over x plus 4. And I'll multiply the right fraction by x minus 4. I want the denominators looking exactly the same. By doing this, it will get our denominators the same. So multiply it in. The numerators, always simplify the numerators. So x plus 4 plus 16. Denominators, I don't multiply those in. Leave those as factors. Plus, distribute just 3 in. 3x minus 12. Again, denominator. Don't actually multiply them out, just keep them as factors. Now we have like denominators, so let's combine our numerators. We have 4x plus 3x is 7x. We have 16 plus negative 12, which is positive 4, so plus 4. And the denominators, x plus 4. We have two of them, so you technically could do x plus 4 squared. And times x minus 4. I look to see now again if I can simplify, factor the numerator. 7x plus 4. I cannot, so that is done, finalized. Alright, so I wrote down all the steps for us. First, factor all the numerators and denominators if possible. Second, multiply to get like denominators. Third, add or subtract to get one fraction. Fourth, factor the numerator if possible. Fifth, simplify if possible. You do these 5 steps and you'll be on your way to success with 5D Part 1. Thank you. Thank you.